Yeah. All right. Good morning, everyone. Thank you so much for coming. But before I begin, I'd just like to acknowledge the traditional owners on the land that we meet here today. And I would like to pay my respects to the elders past and present. And as such, I'd just like to welcome you to our HackMelbourne Decoded event. This event is here to help you get up to speed with Python and object-oriented programming. If you're familiar with that, great. But if you're not, this will help step through sort of what is object-oriented, and it'll walk you through sort of creating a GUI in Python, and then creating like logic for the chess engine. And we'll walk you through the steps. And we have like a GitHub because we put all of this on like a wiki. If you are pretty experienced and you just want to speed along and just like play with it, that is more than welcome. It's there. We'll introduce it as well later on in the workshop. This workshop will be split into 4 parts. The first one will be short and simple. We'll do like a little bit of introduction in case if you're unaware what object-oriented is like, or just like a quick refresher. And then we'll move on to sort of creating the template or like the skeleton code just so you can actually see the chessboard. Then we'll implement some movement because you want to be able to move your pieces, and then logic because you don't want to move your king to the other side because that's just funny. So without further ado, I have A here introducing us object-oriented. Take it away.
All right. Thank you. Hi, everyone. I'm A. So today we're gonna make a chessboard and we will be using object-oriented programming. So I'm giving an intro on it. Anyone not familiar with object-oriented? Good. Okay. Then we'll be that way. What is object-oriented programming? So it's just programming using objects, right? So it makes your program more modular, right? Modular means you can make it, it's more reusable, it's easier to update, it's easier to upgrade. It's like using functions, but in a more general sense, right? And these are the languages that support OOP, Java, Python, which we'll be using today, and C++ and some more, right? So object-oriented programming uses classes. So what are classes? Classes are just blueprints, right? So in OOP, you make a blueprint. Using the blueprint, you create an instance, which you call an object, right? And in the blueprint, you have these things called attributes and methods, which are just data and functions that you put into the class. And these variables are called attributes. These functions are called methods. And anyone know what the difference between a function and a method is?
Method relies on the state of the object.
Yep. So method relies on the state of the object, and function, you can just call the function right away, right? But for a method, you need an object to call the method. Okay. So this is an example of a class, the blueprint. So first you have class cat, which declares the class. And then def init underscore underscore init underscore underscore, right? So that method is called the constructor. Everything in the constructor, in the init constructor, will be called immediately when you call the instance, right? When you define an object. So you have def init self name age, self.name is equal to age, self.age is age. So those two are attributes, they're the data. And the def are the methods because they're functions. Functions within the class is called a method. And then you define the object, right? For the object, I named the object Kaya, right? That's my cat's name. And I declare, and I said cat bracket Kaya, comma 3, meaning I have a cat object called Kaya. I'm going to give it the name Kaya and age 3. If I print Kaya.name, I'm going to get Kaya, and Kaya.age, I'm going to get 3, right? And if I call the method meow, it's going to print meow, right? Pretty simple, right? Anyone got it? So this is an example that I have. So this is the class, the blueprint of the Eiffel Tower. Those are the objects, the instances of the Eiffel Tower. With the actual one, you have the toy one. You can create multiple objects from the same class. That's what I was trying to say. Right? You can have one class, but you can have many objects relating to that class. Right? Now we're going to talk about the 4 pillars of object-oriented programming. First, abstraction. Anyone not know as abstraction? Pretty sure you all know abstraction. So it's a process of simplifying problems into more modular class and objects, right? So in this example, I have a recipe, making a brownie, right? Having a recipe is an example of abstraction, right? Instead of studying the science behind making the brownie, you just use a recipe that says this many grams of sugar, flour, egg, so on, will give you this exact brownie, right? And that's just abstraction, right? And of course, you have the methods as well. So that's data, that would be the methods in this example. So in abstraction, in the cake making process or the brownie making process, you just follow some rules and steps to make the batter, the cake, and then you make the cake, right? You don't need to calculate, you don't need to analyze the science behind what temperature you have to set it and how long you have to set it and so on. You don't need to know what type of ingredients you need or how much you need. Everything's being calculated in the recipe, right? It's being pre-analyzed. So you don't, so that's abstraction, right? Follow the rules, you get the brownie. Good. Next is encapsulation. So encapsulation is pretty simple. It's just hiding the code and the data together from the outside world, meaning back here, I don't need to show what my code is, right? The class doesn't need to go. I don't need to show what my class is. I can just call Kaya right away and I get all the outputs that I want, right? I can access the data and the methods and everything. I don't need to show the code. And that's what encapsulation is, right? Here it says creating a class is an example of encapsulation. Binds all the data and the methods into one entity called cat in this case. And the data, all the data and the methods can be accessed by calling the object, right? In this case, it's Kaya. Next one, inheritance. So you can create multiple classes and pass down the data and the attributes and the methods from one class to the other, right? In this case, I have cat and lion. So of course, we know lions are a type of cat, right? So I have cat that can meow, lion can roar, but of course I can meow as well because I passed cat into lion, right? So if I create an object called Simba with the class lion and I name it Simba age 30, if I print Simba.name and Simba.age, I'll get Simba at 30, right? And because I passed meow in, I can call meow right away. I don't need to declare it here. I don't need to write the code here, right? I've passed it on from cat, right? And then I declare roar as well, so it can roar. Okay. Anyone not clear with that? Good. Right. Next is polymorphism. Polymorphism means you have one function that can do many things depending on the condition of your code, right? Here I have the class shape, and I'm creating 3 other classes called circle, rectangle, and triangle, right? In each class, I have init, which is kind of necessary to have, and then I have area, right? In the shape class, I have area defined, but there's nothing there, right? But in the other classes, I've defined area to be something else, right? So when I create the object called circle, rectangle, and triangle, with circle has to be 5, rectangle 4, 6, triangle 3, 7. It's gonna give me the area when I call this. So shapes equal circle, rectangle, triangle. For shape and shape, so for each shape that I have, I'm gonna print the area, and it's gonna give me 3 different area calculated with the 3 different formulas here, right? It's not gonna go to shape, it's gonna grab the nearest formula that it could get, which is area in the class itself, right? It's not gonna go to the parent class, it's gonna take it from the nearest class. And that's the end of intro. It's very quick. Any questions so far? Nope. Okay. I thought we could do a little demo. So do you guys want to pull up Visual Studio or whatever you have to code? And then I can pull up.
Make sure you speak up, yeah. Are you? Yes. Yes. Yeah.
Okay. You guys see? So for the demo, I'm gonna create a sort of a bank account system, right? A bank, I'll have a class called account. I'll have a savings account, a checkings account. I can withdraw from it, I can deposit money from it, and I can apply interest on it, right? That's it. Or I can get the balance from it, right? Easy, just 4 things, that's it. So I'm gonna have class account and type. It's just passport. A class called savings account. So now another class called checkings account. And I'll pass for now, right? So for savings account and checkings account, I want to inherit the properties of the class account. Okay, so that I can generalize things and reuse my code, right? So I'm gonna do account. This is how you pass. Yeah. So this is how you inherit data or methods from the class account, the parent account, to the other ones. Right. This is how you pass it on. Put a bracket, name of the account. So here, account is called the parent class. And this is just your child class or your daughter class. Yeah.
What if you were to inherit savings account instead of account? Can you still access all the methods of account?
Oh, so in here, instead of account, I do savings account. Yeah. 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 Because savings account, you can access, so the data from account will be inherited by savings account. And if I do this, things from the savings account, which includes things from account as well, will be transferred. Yeah, good question. All right. So let's start with init. So init is the function that calls itself straight away, right? When you initialize, when you start creating an object, this code runs automatically. You don't need to call it, right? Things in init will be run automatically. You have self, count, number, and balance. So self is just referring to the class itself. And account number and balances, these are the arguments, the parameters. Okay. And then I'm gonna say self.account number equals to account number. Now, so what does this do? So here I have self.account number. So this variable is referring to the class account itself, the class called account itself, right? And this variable is the parameter, the value that I get. Oh, the value that I get here, right? These are the same thing. But this one is referring to the class account itself. It's not this one. It's not the same as this one. Okay. And then I have self.balance because I want to get the balance. Right? I have account number, I have balance, then I can deposit and withdraw and get my balance and stuff. So first I have that, and then I'm gonna deposit some money, self amount. What I'm gonna do is if I call the function deposit and give in and pass in an amount, I wanna add that amount to my balance, right? So I'm gonna say self.balance plus equals amount. Simple. Right. I can do the same thing for withdraw. So withdraw amount instead of plus, it's going to be minus. Right. Everything here clear? Good. Okay. But here's the thing though. I can withdraw money past my balance, right? If I have $100, I can withdraw 150. So I'm going to say if the amount is less than equal to self.balance, then I will let it go. Wrong place here. If amount is less than equal self.balance, if I have sufficient funds, then I will let it go ahead and subtract my balance, right? Otherwise, I will say insufficient funds, right? And then I'm going to write my final function, final method, which is to get the balance, right? I want to ask what balance I have, then this function will give me that. I'll name it get balance self. That's it. I don't need to pass anything. And it'll just get me self.balance, right? The balance I have for that object. Okay. So this is the final account. If you're done, I'll move on. Now let's do savings. So in savings, let's think about savings, right? In the savings account, you can apply interest, first of all, right? You should be able to check your balance. You should be able to withdraw from it, deposit money to it. And because it's a savings account, you'll have an interest, right? But because we've written everything for deposit and withdraw and get balance, we only need to implement the applying interest part, right? So before we apply interest, we first have to initialize the methods and the data for applying the interest, right? So I'm gonna say init self account number balance and the interest rate, TREST, and the interest rate, right? Here I'm passing in the account number, my balance, and the interest rate that I'll get from my savings account. And this is a thing that you haven't seen before. So super, super is a function. It's a building function that gets the parent object passed into the class, right? So this is just saying if I have an account object, then I'm gonna get the account object, and then I'm gonna call init to it, right? And I'm gonna pass an account number and balance, which just initialize it, right? So all the data that's passed in here, because I don't have the code written for this, like self.account equals to account number and self.balance equal balance. I don't have that here. I'm just calling super so that it gets initialized here, right? And then I'll say self.interest rate equals interest rate, right? Right now I'm just initializing things. There's nothing going on. But now I will apply interest on self, right? So I have an interest amount. I want to apply the interest. What happens? If I apply the interest, then my balance is going to change, right? Self.balance is going to be equal to self.balance times self.interest rate, right? I'm adding to my balance the interest. That's it. Right? Clear? And now for the checkings account. Checkings account, same thing. I'm going to initialize init self account number balance. And for the checkings account, I am going to put a limit on the overdraft, like how much more money can I withdraw, right? So I'm gonna write a variable called overdraft limit. And then same thing above, super dot, just calling init so that things above gets initialized here. Pass in the account number and the balance. And then self dot overdraft limit is equal to overdraft limit. Right? Same thing here, right? Just initializing values, nothing's going on here. Okay. So now with the checkings account, I can withdraw money, right? I can deposit money, I can withdraw money, but in the withdraw money, because I have the overdraft limit set here, I can withdraw past my balance, right? So I'm gonna say define withdraw. So this is the part, the polymorphism part, right? I have withdraw. I wrote the function for withdraw here, but here I'm overriding it with this one. Okay, so if I have an object with checkings account and then I call withdraw, this is what will be run, not this one. Okay. So I'm going to define withdraw self and amount. And I'm gonna say if the amount that I have plus the overdraft limit, right? If this total amount is greater than or is less than what I'm withdrawing, then I'll continue. Otherwise, I'm withdrawing more than what I'm allowed to withdraw, right? So I'll print an error. Here I'm gonna say if amount is less than equal to self.balance plus self.overdraft limit, then self.balance minus equal overdraft limit, or the amount that I'm withdrawing. Right. Otherwise, I'll just print an error. Overdraft limit exceeded. Okay, now we have the functions and we have classes and everything written. So we're gonna create the object, right? We're gonna create the instance of an object. So let's say savings account equals savings account. This is the class. And what do I pass in, right? So here I pass in account number, balance, and interest rate. So account number, let's just say ABC123, right? Account number, my balance, I have $1,000. Interest rate 0.05, right? 5%. And let's say I have a checkings account as well. Checkings account, wait, did I spell it? It's gonna be checkings account. Let's name it DEF 456. I have 1,500 in my checkings account. And the overdraft limit, right? And let's set the overdraft limit to, let's say, 300. Now, if I run it, oh, syntax error. What?
You got a slash on one in the else thing.
Oh, here. Thank you. So if I run it, nothing's happening, right? Because I just created two objects. I haven't done anything to it. I haven't called the functions. Nothing's being done currently. So I'm gonna call a function, a method, savings account dot, let's say deposit 500, right? So originally I have 1,000, then I'm gonna deposit 500. And for the checkings account, let's say I withdraw 700. What do I get now? Still nothing, right? Because here what am I doing? Withdrawing and depositing money, but I don't have any print statements going on. So of course nothing's gonna be printed, right? But in the checking account, because I have 1,500 in my bank account and 300 is my overdraft limit. Let's say I want to withdraw 2,000. Overdraft limit exceeded, right? I can withdraw 2,000 because I am only allowed to withdraw 1,500 plus the overdraft limit, which is 1,800. Right? So that's just 200. Next, let's try applying. No, let's not apply. Let's try printing it first. Let's print savings account balance is going to be savings account dot get balance. Right? Remember, get balance is the method I have where I just return the balance. That's it. Right? So if I run this, I'm gonna get 1500 because I passed in 1500. Wait, where is it? Yeah, because I have 1000 here and I deposit 500, so it's gonna give me 1500. Right? And then let's print. Oh wait, I can just copy this. Same thing, I'm doing it for the checkings account. Get balance. What's happening? 1500, withdraw 300. I expect to get 1200. What do I get? 1200, right? Now let's try applying the interest in the savings account. So where is it? Apply interest here. If I want to apply interest, I'm just gonna say savings account dot apply interest. I have the function and that's it. I don't need to pass any parameters in here because apply interest doesn't have any parameters. It's just have self, which is kind of mandatory to have, right? So I have 1500 plus 0.05 of 1500, which is going to be this much, right? And that's it. You can play around with it. Not really. Let's say I have savings account withdraw 1600. What happens? I'm gonna go over my budget. Am I allowed? Oh, yeah, I'm not allowed. So yeah, that's it for the demo. Any questions? No. Did you guys all write it up or does it run? Good job. All right, that's it.
Okay. Okay. So thank you, A, for the introduction to like object-oriented programming. I hope you all have like a basic understanding of a bit of Python object-oriented programming, just the principles and how to use it. Because it's this is what we are going to do, like something similar to this for our actual chess programming application in Python. Yeah. But before we begin with that, we have food. It's almost 12, so let's get some Subway for everyone. And also, while everyone is getting Subway, we'll also help you guys set up your like code editor and like install the important things for like the chess programming section of the workshop. But yeah, after lunch we'll get started with chess.
Yeah, I guess we will be starting the next session at about 12:40.
Yeah.
Let's start at 12:40. All right,
Yep.
see y'all till then. Thank you.
Do you want to share the show the wiki page to set up? I'll show it.
Yeah, you can leave it on.
You set up. You send. Okay. Yeah. So if you guys want to set up like everything related to like the chess game, like installing the images for each chess piece and like the base code for the chess game, you can follow this page over here. Yeah, and just follow along. Let us know if you guys have any problems.
In case if you can't find it, literally just go to Google, find HackMelbourne GitHub, and then just like look for a GitHub. You should see like something called DecodED in one of our repository.
if you open this, you can just click on wiki, and this is basically what we're covering today.
Yeah.
If you want a little head start, just look at part 1. This is the part that I'll be doing later. And we will need to set up a few things, namely, make sure you have your VS Code working, and make sure you can actually run Python on it. And then if you want to try, you can also try using Git later to get the skeleton, like all the pictures that we've already made. And then you would also need pip because you want to be installing some packages. So if you try running this in your command line and it doesn't work, you may want to try installing pip or the equivalent of whatever you want to use.
Just Google search.
Yeah, or ask us. We'll
Oh,
come
ask
and try
us.
help. And then later I'll start from around here. All right.
Yeah.
Yes. I need to stop sharing. Which one is this?